Students, we are going to look at a very important theorem, that is Green's theorem. Green's theorem. If P and Q are continuously differentiable vector scalar point functions in the region R, then integral P dx plus Q dy calculated for the closed curve C. Suppose there is a curve here, there is a curve C, and R is the region inside that one, and this P and Q are continuously differentiable functions of x and y in that region R. Then the line integral calculated for the outer boundary C is equal to the double integral calculated for dou q by dou x minus dou p by dou y for this region R, dx dy. This is the statement of Green's theorem. Now let us verify this Green's theorem for one small problem. Verify Green's theorem for integral over the closed curve C sum x square plus y square dx plus x into y dy, where C is the triangle formed by the lines x equal to 0. This is, for example, I'll write here the lines x equal to 0, x equal to 2, and y is equal to x. Now the question is given to us where C is the triangle formed. So first of all, I'll draw where is that particular triangle. So let me take this as 1, for example, this as 2. Then this line is x is equal to 2, and this is y axis, this is x is equal to 0, and the line here, this is x equal to y or y equal to x, anyway we can write it. So the region is this particular region. This region, blue region, is this region, and now we have to show that P dx plus Q dy is dou q by dou x minus dou p by dou y. I'll give the names now. Let P is equal to x square plus y square and Q is equal to x into y. That is, I have taken from here. I hope you are able to see this first line. Okay, so we have just given the names as P and Q. Therefore, dou q, better it is to calculate the simpler part. Simpler part is this part. This part is simple in the sense because it can be calculated at one time directly. But if you go for the calculation of this P dx plus Q dy, you have to make 3 parts. First this part, then you have to go for this line, and then you have to come back for origin. So there will be 3 parts, 3 lines, because there is a separate equation for this line, separate equation for this line, and separate equation for this line. So we have to make 3 parts. We cannot directly take as one single equation for the curve. So we have to make 3 parts and do. That is why it is better to do the simple problem first. That simple problem is that double integral. So what I now do is, now dou q by dou x minus dou p by dou y is equal to dou by dou x of that x into y minus dou by dou y of p value. P value is x square plus y square. So that is equal to, with respect to x it will be y, minus with respect to y it is minus 2y. So finally it is minus y. Now what are the limits of the region? I explained in the previous video in multiple integrals. So I will take just a strip parallel to y-axis. When I take a strip parallel to y-axis, it starts at this and ends at this one. Therefore, I will now write it. Therefore, integral over the region R dou q by dou x minus dou p by dou y dx dy is now going to become equal to, you can just see that first the strip is taken parallel to y-axis, so I will write the limits of y. Y starts at 0, it ends at x, and if you expand this strip on both the directions, the strip will have x values starting from 0 ending at 2, and inside the value is minus y into dy first. Even though dx dy is written here, we should follow the order because inside integral is y, that I am writing dy here. So what I now get is dy dx. Just now we'll calculate the integral. So integral x is equal to 0 to 2, minus c is outside. Integral y is y square by 2. Limits are from 0 to x dx. Now I will take that constant to outside, so minus 1 by 2. Integral x is equal to 0 to 2. In the place of y, upper limit x, so it becomes x square. In the place of y, the lower limit is 0, so 0 minus 0 dx. So finally it is equal to minus 1 by 2 integral of x square, that is x cube by 3, limits are from 0 to 2, that's equal to minus 1 by 6 outside and 8 minus 0, so finally it is minus 4 by 3. This is the result for, therefore double integral over the region R dou q by dou x minus dou p by, I'm sorry, it should look dou p by dou y dx dy is equal to minus 4 by 3. If the question is there, apply here. Be careful all of you. A very important point I am showing now. Apply Green's theorem. Apply Green's theorem for or to evaluate. To evaluate this integral where this same problem, then your answer is over, because this dou q by dou x minus dou p by dou y is nothing but, therefore by, you have to write by Green's theorem, integral over c p dx plus q dy is equal to minus 4 by 3. The matter ends here. If the question is apply Green's theorem, but here it is verify Green's theorem. So what we are now going to do is, we are going to show that line integral calculated for this triangle. So first we have to calculate in this direction, starting from a to b, then from b to c, this is second part, from c back to a, that is third part. So whatever line integral comes for first part, for second part, for the third part, we have to add up all, then we will get the complete line integral for the triangle C. So this is the problem where we are handling for verification, and hence we have to do all these things.